to be sure that we capture all of this because it's so important. So, let me just, a couple more people coming in and we'll get started here. I'm sure there'll be more as we go.
Mark, if you make me co-host, I should be able to help let those people in.
Absolutely. Good idea, Jen. Make you a co-host. There you go.
Great. Okay, good.
We're good?
Yeah.
All right. Well, let's get started. So first of all, welcome everyone on this beautiful sunny day here in Toronto. We finally have one, which we're going to take. My name's Margaret Wallace-Duffy, and I'm the founder of Preventative Health Awareness Month and Movement, recognized by Health Canada. And I'm also a proud registered massage therapist with a background in kinesiology and owned an award-winning preventative and integrative health clinic that I operated called Wallace for Wellness for 30 years. What is Preventative Health Awareness Month and Movement? Really, it's about breaking down the silos in healthcare and bringing both sides of the equation together, complementary and conventional medicine together to learn and grow from one another. But the biggest and most important piece of that is helping everyday people get into the driver's seat of their health. And how do we do that? We do that through education and things like today. This stuff lights me up. Pun intended. And the reason being, how do we get into the driver's seat of our health without having the education and the empowerment to make informed decisions? And now at a time in healthcare that is very strained, where people are living longer but not living well, this pill for an ill, wait till it's broken sick care system, all of us are strained. Many healthcare professionals are strained, and there's many healthcare professionals that have asked to get the recording of this call. So today, we're really excited to have a world leader in molecular hydrogen with us, Dr. Tyler LeBaron, to do exactly that, to not only talk about what is this thing called molecular hydrogen, but more importantly, how can it be integrated into our daily lives? How can it help both practitioners improve the health and well-being of the patients they have the privilege of treating? And how can it help everyday people in a simple yet powerful way to change their health mentally, physically, and improve longevity so that they can live with health span, not just lifespan? That's what the preventative health movement is about. In 4 short years, it's gone from just me to over 95 healthcare professionals and climbing. All levels of our government are paying attention. But more importantly, we're impacting so many people with allowing them access to information like today. And one of those ambassadors is on the call with us today, Jen Newman, a fellow massage therapist, cranial sacral therapist, ambassador, and a friend who I have mad respect for, not only for her professionalism, but for her heart. She cares about learning, leaning in and learning, but helping stock the toolbox of her patients and learning and growing from one another, which is what today is about. So Jen, how excited are you? Like, I'm so
Oh,
pumped.
I'm so excited to have Dr. Tyler here with us today and to be a ambassador because I really understand that working with other health professionals to help empower others about having agency over their health and really understanding that healthcare is what we do today is protecting us for tomorrow. And having tools like what we're going to talk about today with molecular hydrogen is so important. When I started using molecular hydrogen, I was really surprised at how it started supporting and feeling more calm and regulated. I think it was the first time in my life I've actually felt regulated. And someone who works with the nervous system and helping people support nervous system regulation, I started to see this as an incredible tool that anybody can access. And for me, not only was it starting to support me as an athlete in my cycling and how I was performing and recovering, but I was starting to see that I had more capacity to deal with the demands of my life. And that was helping me in how I'm showing up as a therapist, how I'm showing up as a yoga teacher, and even when I'm facilitating breath work. So that is what I found is really important. And when you combine that with something like cranial sacral therapy, we're starting to see how important it is to go back to the basics. Molecular hydrogen, from an evolutionary standpoint, has been here since the Big Bang. And when we can take molecular hydrogen through water and transport it through the body, those are two things that in cranial sacral we talk about as the inherent intelligence of the body. And molecular hydrogen carries signals through water to help the body heal in its own way. And that's just so important because it makes healing today so accessible for tomorrow. So Doctor, of course, I'm not going to go into the science because we've got Dr. Tyler here to talk to us about it. So let me just share a little bit about who he is so we all know who we're talking to today. So Tyler is the founder and executive director of the science-based nonprofit Molecular Hydrogen Institute. His background's in biochemistry, physiology, and exercise science. So as an athlete, I just really value that. He has taught physiology and currently teaches exercise physiology and chemistry lab classes at Southern Utah University as an adjunct instructor. He's interned at Nagoya University, Japan, in the Department of Neurogenetics to research the molecular mechanics of hydrogen gas on cell signaling pathways. Tyler is a director of the International Hydrogen Standards Association and the International Molecular Hydrogen Association. He speaks at medical conferences in the US for doctors, CMEs, CEUs, and as an academic biomedical hydrogen symposia and conferences around the world. He's actually joining us today from the airport in between conferences. So he's a member of the Hydrogen Biomedical Research, and he collaborates with researchers at home and abroad and helps advance the education, research, and awareness of hydrogen as a potential therapeutic medical gas. When not doing research, Tyler, this is what I found so fascinating about you. When you're not training and competing and doing sports, you're a competitive arm wrestler.
Yes, it's kind of a new thing I've taken on. It's been pretty fun for me.
That is impressive. Well, thank you, Jen, and
Yeah.
thank you, Dr. Tyler, for taking time out of your day to be here. And so I think it's best to let's just kick this off and get right into it. And for those, I mean, many on the call are aware about molecular hydrogen, many aren't. So why don't we start with the basics and I'll turn it over to you. What is this thing called molecular hydrogen?
Yeah, absolutely. Well, thank you, Jen, for the intro and Mark for allowing me to be here to talk about something I am very passionate about. It's something very exciting. I have prepared a number of different things over the years, and I do have a presentation that I think will address just that. So maybe some visuals will help, and we'll try to break down some of the science. So if I can share my screen here, if you are able to allow me to
Of course.
give me that permission, that's so kind of you. Wow, it's good service. Let's see. I'll do. I think this is the one I want to do here. Okay. Okay, can we see my
We sure can.
screen?
We sure can.
All right. Um, let's see. Is this the one I want to do? Let me check this again. I have we have yeah, that's right. Okay, good. Okay, yeah. So as mentioned, yeah, I have a number of academic affiliations and things, and to disclose my conflict of interest, I am a scientific advisor also to several companies, including Lumavite, which I think is great that companies want to get the information correct. They want to understand what the science is really saying. So I think that's a good thing. Um, but first, to get into your question, I actually have a question for you guys. Molecular hydrogen, it refers to what? Is it the H in pH? Is it the H minus ion? Or is it the diatomic gas? Or is it the H plus cation? And the answer is C, the diatomic gas. This is really important when we distinguish what hydrogen is. This is the H2 molecule, right? When we think about the hydrogen atom, like on the table elements here, we have the hydrogen atom, and that hydrogen atom can combine with a whole bunch of other things. For example, it can combine with oxygen to form water, right? We have H2O, or it can combine to form with carbon to form hydrocarbons like carbohydrates, or it can react with another hydrogen atom to form hydrogen gas. That's diatomic hydrogen. And that's the molecule we're talking about. That this is an illustration of that. We have the molecular form, right? So there's the two hydrogen atoms that are sharing these electrons. There's two protons, two electrons. Then there's the hydrogen atom. And then these other forms where the hydrogen anion, you have like an extra electron, or if you take away the electrons, it's just a hydrogen cation. That's the proton, right? That's actually what is responsible for the H in pH, is what makes things acid or base. And then the hydrogen compound I mentioned, you can see hydrogen is part of these other chemical compounds, but is materially different, chemically different, distinct species than the molecular hydrogen that we are talking about. So it's important to distinguish this form of hydrogen because there's a number of different forms or ways that hydrogen can be found in nature. Well, why is this important and exciting? Well, that all started here in this publication in Nature Medicine. This was in 2007. And if you just look at these images here, okay, there's 0% hydrogen gas and 2% hydrogen gas. And what I want to explain is that this is the portion of a brain of a rat that was given a stroke, basically. It was as a stroke model. And so if you, of course, with the stroke, you don't have the blood supply, the oxygen, and you're going to cause a lot of brain damage. And this is a ischemia reperfusion injury. And with the 0%, you can see the white area of the brain tissue. That white area represents the dead portion of the brain. But when you administer just 2% hydrogen gas, what they did is they filled the animal cage up with 2% hydrogen gas. And when they did this, you can see there's a lot less dead area of that rat brain just by 2% hydrogen gas. Well, how is that possible? Well, it turns out that hydrogen, in this case, acted as a therapeutic antioxidant by selectively reducing cytotoxic oxygen radicals. So that's a very key part of how hydrogen gas can do that. We're going to talk more about this mechanism, but that was in 2007 in Nature Medicine. Now, there's different ways to administer hydrogen gas, like inhalation, like here I'm at a clinic in China. There's also this hyperbaric idea in Japan. And then there's simply drinking hydrogen water, which is actually the most common and arguably the most convenient way, is simply to ingest water with hydrogen gas in it. Now, it's important we consider the molecular hydrogen bioavailability, because we know that the first principles of pharmacology is, can you actually get it to the cell, right? What difference does it make if it's all great if you're not going to put it get into the cell? And a lot of your drugs, see, they actually are going to be broken down by your stomach acid or bacteria, or can't be absorbed through your intestines. And then even once they are get into the bloodstream, they're not able to penetrate the cell membrane because it's a lipid bilayer. So they have to go through maybe different protein transporters. Think of like vitamin C even. Vitamin C, in order for that to go inside of the cell, because it's a hydrophilic, water-soluble molecule, it has to go through a specific transporter. Whereas molecular hydrogen, it doesn't need any of that. It can simply diffuse through the cell membrane and go into the cytosol, the mitochondria, anywhere very easily without the need of any types of transporters or protein carriers or other things, right? So that makes hydrogen very unique, is just that it has such a high bioavailability. Now, when it comes to hydrogen water, it's one of the main methods to get hydrogen water. We can look at what we call the pharmacokinetics. So if we look at this, the y-axis here, what we can see the increase in H2 concentration in the breath. Okay, so when we're breathing, we exhale, and that exhalation contains gases, right? Nitrogen gas, it has oxygen gas. We don't use all the oxygen gas. And it also contains some gases produced from maybe our intestines, or maybe in this case from molecular hydrogen. And so we can measure that gas. And then the x-axis is the time after drinking the hydrogen water. We can see it starts to reach a peak level within just a couple of minutes. 5, 10, 15 minutes, depending on the dose being administered. It reaches a peak level, and then it goes back to baseline within an hour or so. So if we go back earlier to that other slide, we saw that hydrogen gas is a very high permeability, very high bioavailability, so it can penetrate the cell membrane very easily. And this is somewhat indicative of that. The fact that we can see increases in breath hydrogen gas within like 30 seconds is very quickly. We can see the increase, those penetrating the cell membranes, going into the heart, then to the lungs, and then being exhaled out the breath very quickly, and then reaching that peak. And then importantly, we can see as it goes back to baseline within 60 minutes, what does that tell you? It doesn't build up in the tissues. It's not being stored in some organs or some like maybe adipose tissue or something, and then over time becoming toxic because it's accumulating, and then what are you going to do after that or something? It doesn't stay in the tissues. But that does raise the other question then. Well, if it's not present, then how can it provide any benefits once it's gone? And that's the real cool thing about hydrogen, is because it's not typically just an antioxidant, as we're going to see. It's rather more of a signaling molecule, a signal modulator. We're going to talk about some of those mechanisms. So we can actually see benefits of hydrogen even after the hydrogen gas has left the body. So another thing I want to go back, though, is this type of concept of water having benefits has been around for a long time. One of the first was known as this electrolyzed reduced water, or alkaline ionized water. Back in the 1930s, it was being used. 1965, it was approved by the Japanese Ministry of Health, Labor, and Welfare. And 1980s, there's a lot of testimonials regarding the potential benefits of this water. I'm sure many on this call have heard about this type of water and the claimed benefits, and often the benefits are not really supported. But either way, people have heard a lot about these types of things, right? Well, it turns out this water can have benefits, but the question has been why? How is it even possible? Like, is it from an alkaline pH? Is it because it has, this unique chemistry, some water structure or something like this? Like there's so many questions and claims, and those things have been investigated actually extensively, and none of those claims were found to be correct. But there was one thing that happens. When you do electrolysis of water, by definition, what is the definition of electrolysis? It's merely the decomposition of water into hydrogen gas and oxygen gas. So you can see in the red arrow here, at the negative electrode, okay, that's a negative sign, those electrons are being added to the water. They combine with hydrogen ions and they make hydrogen gas. That's molecular hydrogen. So the very definition of electrolysis means you are producing hydrogen gas. And then that would raise the question, well, those of you who are familiar now with the benefits of hydrogen gas, you could start to think, well, maybe it's hydrogen gas responsible for these benefits. And indeed, that is the case. It's been shown over and over again. So this is a little graphic that we created for a publication, but it basically shows all these types of claims that people had made out there about like hexagonal water, or microclustered, or alkaline pH, or what have you. And all those claims have been categorically refuted scientifically by some of the research I have done, as well as numerous other researchers and just basic scientific principles. However, what has shown the test of time is indeed molecular hydrogen. And now that we know that the benefits are exclusively related to molecular hydrogen, well, we can focus on getting molecular hydrogen through other methods. For those who are interested, you can take a screenshot of this or something. This is an article we published several years ago. It's a comprehensive review article showing that molecular hydrogen is the exclusive agent responsible for these therapeutic effects in ERW. This is not just a single publication, but an analysis of a whole bunch of publications. So anybody who has questions about that water, this is the Bible of the history and the evidence of where things are at, okay? Now let's go back to this study. Again, we talked about how the 0% hydrogen gas had, you can see all the dead area, but 2% was very effective. There's a couple of important things to point out. Number one, also that 2% is not flammable, because anything above 4% is when it starts to get explosive. Remember, hydrogen gas is explosive. It's 3 times more energy dense than gasoline. And so you heard of things like the Hindenburg or rocket fuel or things. Hydrogen gas is very explosive. But see, when it's less than 4%, you don't have to worry about it. Or when you simply dissolve it into water, you also don't have to worry about it. All right. Now, in this study, the focus was showing that hydrogen gas could reduce oxidative stress. And I mentioned that it's able to reduce the toxic free radicals, because you have good free radicals and bad free radicals, but it only went after the bad ones. And so the mechanism for a long time was this concept that it was a selective antioxidant. However, we published a major paper. I'm going to talk about that in a minute. This is a really important concept in that same article, really illustrating how we know that hydrogen only goes after the bad guys. And on the y-axis of these different charts here, these different graphs, we see basically the concentration or the intensity of this HPF marker, which is a marker of various radicals. In the graph C, we see C, which is the hydroxyl radical, and that's the bad guy, right? You don't want hydroxyl radicals. Those are the most toxic or reactive oxygen species because they react with pretty much anything. You cause DNA damage and propagation of radical species and so on. So you want to get rid of that. And turns out molecular hydrogen was able to reduce that. But so is vitamin C. Right? That's a well-known antioxidant. Vitamin C could do that as well. Peroxynitrite, that's the next one. This is a very strong oxidant, and it lasts longer and diffuses into tissues, and potentially is even more damaging than hydroxyl radical just because it can diffuse so far and cause lots of damage. And it turns out hydrogen gas could also reduce the amount of peroxynitrite. But now we turn our attention over to superoxide, the hydrogen peroxide, H2O2, and the nitric oxide. Now, these can be bad when the concentrations are too high and the concentrations in the wrong location for a duration that is too long. But they can also be very important. Your immune system produces these radicals for getting rid of the pathogens. Your mitochondria uses these radicals and these oxidants for signaling purposes. So you actually want them. And so in these cases, you can see if you combine hydrogen gas with these radicals, there's no reaction. It doesn't get reduced at all. But if you add, say, vitamin C, yes, vitamin C was very effective at getting rid of them. So see, vitamin C is a non-discriminant antioxidant. It neutralizes all of them, the good, the bad, the ugly, but right. So it's also the beneficial ones. Hydrogen gases did not, indeed cannot actually do that because it's a stable covalent bond. It only selectively goes after the hydroxyl radicals and to a lesser extent peroxynitrite. This is a major distinction of molecular hydrogen of why it's different than any other type of antioxidant out there because it's selective in that nature. It only is going to go after the bad guys. But the story is even more powerful than that when we understand today the better the mechanism. And that is this article here we published last December in Redox Biology. We found this protein in complex 3 of the mitochondria, this risque iron sulfur protein, is a target of molecular hydrogen. Now, to break this down a little bit more, in the mitochondria, this is the powerhouse of the cell, right? It produces 90% of all the ATP. And the way it does it is it takes your food and it pulls those electrons out of your food and carefully but meticulously gives those electrons to oxygen and it makes water. And it does that by passing electrons from one complex to the next, to the next, to the next, basically. And at complex 3, so it's one of the complexes where electrons are being transported through. In these complexes, sometimes those complexes will donate an electron prematurely to oxygen and then create free radicals. Sometimes that's a good thing, sometimes that's a bad thing. It depends on so many situations, right? Again, free radicals can be good or they can be bad. It's not just black or white. Well, hydrogen specifically targets the risque iron sulfur protein in complex 3. And when this occurs, it basically causes what we call a mitohormetic effect. In other words, it's almost slightly toxic, it turns out, to the mitochondria, because it kind of makes the mitochondria like, whoa, what's going on? And it kind of perturbs or slows down that rate of transfer just a little bit. And the mitochondria then realizes, something's not quite right. I need to do something about this. And so it causes what's known as the mitochondrial unfolded protein response. And this increases and it results in the regeneration and rejuvenation of the mitochondria. So now you have higher function mitochondria. So we actually see this change within 2 minutes in cell culture. And then after that, we actually see increases in ATP production and increases in other mitochondrial proteins and so on. So this is why many studies are showing over and over again improved mitochondrial function. And this is the key mechanism that pretty much explains all the benefits of molecular hydrogen because the mitochondria is key for energy production, is key for regulating the free radicals and antioxidants, and then key for the inflammatory response and just improving the overall resilience to stress that cells have. So this is a really key aspect here. Just some more slides really showing what I said, that first we have see a decrease in this protein and then quickly we see an upregulation of this protein. Okay, now go into some other studies with some animal studies that are pretty cool with say dementia, for example. This was an experiment that was done to see if drinking hydrogen water long-term could prevent dementia. And in this experiment, the mice were genetically susceptible to develop poor cognition and basically the inability to remember. These are the DAL, D-A-L. And so just remember that because we're going to see some graphs later. That they were administered hydrogen water from either 1 month or 8 months to 18 months. And remember, these mice, they only lived for 20, 24 months. So it's important to consider that because if that's 24 months, that's if you compare it to an adult that's going to live to 80 years old, then giving them water at 8 months, that's like mid-age, right? Then they wanted to test the memory. And the mice were placed in a cage with 2 different shaped objects for 10 minutes. And then the next day, the mice were placed in the same cage again with a new object. So if the mice remember that object, well, they don't really show interest. But if they don't remember it, well, their behavior is the same as if they'd never seen it, right? That's one of the benefits of dementia is you get new friends every day. Probably a bad joke. So then they take these mice and they compared them to the wild type mice, right? They don't have these genetic deficit. And here's what we find. The drinking hydrogen water for most of their life, right, for 1 month to 14 and 18 months significantly improved the memory. So you can see in this, the recognition index here. So WT, that's the wild type, that had the normal score. And then the DAL, the minus, so there's no hydrogen was given at all. You can see the recognition went way down, right? It decreased significantly. But when those same genetically compromised mice drank hydrogen water, their memory scores went way up. And then when you tested that at 18 months, it was even more substantial, right? The ones that didn't have any hydrogen water, it was huge. They didn't recognize anything. But the ones that drank hydrogen water, it's almost like they didn't have a genetic susceptibility to dementia. So this is a really powerful study. Again, it was in mice, but it's saying that perhaps it's best to start drinking hydrogen water before we get old, right? But then the question then is, well, okay, what if you would have started drinking it at midlife? Okay, so what if you're like, look, I'm not a child anymore. I'm already 40 years old. Is it too late to even start this? Well, this is what they did here. They found that also improved memory. So they started 8 months to 14. It also improved the memory. So basically, maybe it's not too late, right? We can start drinking hydrogen water now. Again, if you're a mouse, this is a very impressive animal study. The human studies are not quite as impressive, but there are some human studies that show potential benefits. This is just another part too. They showing improvements in markers of neurogenesis, right? GFAP and IBA1 alpha, they're markers, and those are markers of neurodegeneration. So they're actually decreased. So it's some mechanistic understanding maybe why molecular hydrogen is helping with these areas. Okay, but here's a clinical study that I was referencing. This was a year-long study, a randomized, double-blinded, placebo-controlled clinical study, and there's certain people who had the ApoE4 genotype. They really seem to respond well to molecular hydrogen, to drinking hydrogen water, and that's important because if you have the ApoE4 genotype, your susceptibility to Alzheimer's and dementia is much higher. It's like, I don't know, 25% or higher or something, depending on how many alleles you have. But it's much higher. And then if you drink hydrogen water, you can see that over time, you had actually improvements in, like, say, word recall task and the Alzheimer's disease rating score as well. So again, something really neat that we're seeing benefits not only in the animal studies, but there are meaningful benefits that are being translated to human studies as well, simply by, yes, drinking hydrogen water. And these were elderly subjects as well. They weren't, like started when they're children and then wait until, they're 70, 80 years old or something. They're only a year long of people who already had this condition. So that's another neat finding. Another one is the potential of hydrogen water to suppress obesity. This is, again, these rats here, they had leptin deficiency, so they had the susceptibility to gaining fat because they're going to overeat. And with the control mice, of course, they gain a lot of body fat. And you can see in the both of these images here, there's just a lot of visceral fat, some cutaneous fat, and so on. And then the other rat, same genetic defect. I mean, they are brothers, except one got hydrogen water and the other did not. And you can visually see the difference just alone because one drank hydrogen water and the other did not. So it's something so simple. That's why it's something I think a lot of researchers are finding very interesting, because we know that, I mean, one of the best things you can do for your health is to exercise, right? And yet that's hard. That's hard for people to get off their busy schedule or their lazy schedule and start exercising. But to drink hydrogen water, I mean, everybody already is drinking water, right? And so I think it's one of the reasons why a lot of researchers are taking a lot of interest in this, is simply because this is something so simple, so meaningful, that everybody could potentially take advantage of if it truly translates to human research. So there's been some studies in this area. In fact, I was part of one of them with a 24-week study where we took people with metabolic syndrome and we looked at their blood lipid profiles, inflammatory markers, and we looked to see if there were any benefits after drinking high concentration hydrogen water. And we did. We saw some pretty impressive things. We saw their improvements in just their cholesterol levels, their inflammatory markers, their antioxidant status. And we looked at the actual data, like of the BMI. There was also changes in their BMI. So there's actually changes in their weight gain as well. So actually lost body fat, had like improved body composition as well. So another pretty neat thing about just, again, drinking hydrogen water. These are just subjects, just people who just, that's the only thing they changed, just started drinking hydrogen water. Okay, and then another really important part, we talked about how hydrogen is targeting the mitochondria. Well, when it does that, that's probably more of a direct mechanism that in later on ends up causing this NRF2 activation. And the NRF2 is this gene transcription factor that when it gets activated, it induces the production of over 200 different proteins and enzymes that are cytoprotective. And so your antioxidant system, your detoxification system, and so on. And this is kind of the mechanism that we're showing here in this paper we published a while ago. So there's another key area of hydrogen is it's more of a master regulator of our body's natural endogenous antioxidant self-defense system. So it's really going to your body's innate healing ability, its own intelligence, so to speak, because it's able to help the body do what it's already designed to do. So we are now at a revolution, right? As a definition, a revolution is a dramatic and far-reaching change of how we use something or of thinking and behavior. So we have like the hydrogen energy, hydrogen-powered cars, right? And then we're using it now from an alternative energy to an alternative medicine. And now that also is going to cause a revolution in the industry. There's new products that are being developed specifically for hydrogen, right? Some of the first products that were potentially giving benefits of hydrogen, they were not optimized for hydrogen because we didn't really know that's what it was. But over time, optimizations can lead to improved hydrogen products based on the medical research. So we're actually in a really cool time right now with more things coming to the forefront of the industry. And with just so much this awareness of hydrogen that's just growing as well, it's on both fronts. It's a hydrogen for medical as well as hydrogen for energy. And the hydrogen for energy is really taking off. And I feel like in some ways that is sort of obfuscating the real increase of hydrogen gas as a medical energy as well. But it's there as you can see on this graph. It's really taken off. So I do think it's interesting when you look at these timelines. It's interesting that as early as 1793, we published this paper a couple years ago, but I found an article in 1793 that suggested hydrogen has therapeutic effects. And there's a group of doctors that were just inhaling every gas they could create and make, and they found that hydrogen gas seemed to have some anti-inflammatory effects in the lungs, basically. But now the research has really started to continue, right? 2007 was that Nature Medicine publication. 2013, that's when we started the Molecular Hydrogen Institute. And now things are just growing. So what is it going to look like in the future, right? Well, this is what I'm thinking. I think that 2027, there'll be another inflection point. Maybe those of you on the call will help to create this inflection point, right? So this prophecy becomes a prediction of us making it, right? But I think that inflection point will occur. And I predict that by 2037, hydrogen will be widely recognized as a therapeutic gas. I think we're already seeing this prediction come true. When I started this back in 2009, of course, nobody knew anything about this idea. And then even in 2015 to 2018 or so, it's like nobody had ever heard of this concept. And slowly but surely, they started to gain more awareness. And I think that we're on this another inflection point, and it'll have more broad spread recognition. And so everyone I think here is pioneers. That's my belief anyway. But in order for this to happen, we still need, of course, more studies, right? We still need to really elucidate more of the molecular mechanisms, understand which diseases it's most effective for, understand different concentrations, method of administration, right? Like in inhalation or drinking or other things as well. So with that, I just want to say thank you. Again, this is education directly from our Molecular Hydrogen Institute, and you're all welcome to check it out. We're a science-based nonprofit. We just focus on education and research of hydrogen as a medical gas. You can even become certified. If you like this information, you can get certified and you can learn some of these basics about what hydrogen is and isn't, some other principles of critical thinking and so. So we would love to encourage you to do that. And with that, I just want to say thank you again.
Well, Tyler, wow. I got to tell you, I'm sitting here taking notes and transcribing this call so that I can send out the transcript to everyone, because you've just poured into us. And I for those on the call that are healthcare professionals, or maybe you're not, you didn't do well in science in high school. It's okay. And this is what I wanted to sort of pull from you right now. Clearly, the emerging science is hopeful. Clearly, the future is bright with and what I loved about what you were saying is early adopters, and this is what the preventative health movement is about, is having these conversations, inviting people to do lean in and learn from one another so that we can push the envelope. That's how what science does in order, for the future. And that was my goal, to change the legacy of healthcare in this country. It's bold, but because of people like you and your knowledge, it's happening along with all these people on this call. Can you just clearly it's been around a long time. The science is emerging. Yes, we need more clinical studies on humans, but on a very basic level. So, me as a massage therapist, the musculoskeletal health impacts all of us. It's our longevity organ. Can you speak to, and just to the average everyday person, how can molecular hydrogen help them on a very basic level? I love the science. Now I just want to get down to how do they integrate it into life, and what are some of the benefits they could see across the board of, I know, a wide range of conditions. Can you speak to that?
Yeah, I think if we look at the mechanisms of molecular hydrogen, we can start to sort of predict about what some of those benefits are, and this is sort of seen when it comes to people's own lived experience with molecular hydrogen, as some of the things that Jen mentioned, for example. We talked a lot about hydrogen gas ability to target the mitochondria. And when it does that, what are we going to find? We're going to see that hydrogen increases the energy production of the cell. So we can actually have more energy. If you have more energy, then you're able to do normal cellular function, right? If you think about your muscles contracting, that requires energy, but it actually technically requires the energy to relax the muscles, is how it really works. It's ATP is required to relax the muscles, but that's a different topic
That's a
altogether.
different story. Yes.
Yeah, but my point is if you don't have enough ATP production, it's not only that you have impaired exercise tolerance, but that also means you're not able to perform other cellular functions very well, maintaining your cell membrane potential, doing things like autophagy, doing DNA repair mechanisms, and so on. So people who seem to have maybe low cognition or maybe like brain fog, or they just fatigue during the day, all these things could potentially improve just by getting more molecular hydrogen, right? And that's on the mitochondria level with energy production. Then remember, as we target the mitochondria, we're also improving the redox regulation. And we know that oxidative stress, for example, is very pathogenic. It's going to lead to oxidative stress. It's going to create havoc on our cells, of them able to function as well, and that can lead to all sorts of problems. Well, again, if you're able to reduce that oxidative stress because you're preventing the formation of those free radicals in the first place, or because you're activating the NRF2 pathway, you can directly help reduce the stress. You're not going to eliminate it. You don't want to eliminate the
No.
amount of free radicals. We need those, but you're going to modulate this oxidative pathways, and by so doing, you can improve your cellular function. And then that leads directly into the inflammatory response.
Yes.
We know that inflammation is bad, right? Chronic low grade inflammation, or the inflammaging concept, is is one of the hallmarks of aging and disease and so many problems. But we also don't want to just eliminate that inflammation, right? That those inflammatory signaling is absolutely key. It is crucial for our repair, for like recovery, for exercise performance, for infections, for healing, and so on. And so it's really about modulating that response. It's really about being able to get an acute inflammatory response as needed, but not for too long and too excessively. That's going to be prolonged. That will end up only leading to more problems, because as those inflammatory signalings increase, then you end up creating more free radicals, more reactive oxygen species, and that in turn is this helical cycle that just keeps on stimulating the other until you're in a downward cycle, leading to tissue necrosis and ultimate premature death. So hydrogen being able to help with the inflammatory response is another really big one. And then all that together can help with improving the resilience of the cell to cellular stress in general. So again, what are people starting to realize or to feel, whether it's their sleep improved, whether they're feeling more refreshed, whether they have more exercise tolerance or ability, whether they have just less aches and pains, just maybe more self-regulated. all of these things are mechanistically possible, and we're seeing emerging evidence from the clinical data that this, coincides, that this makes sense.
Thank you for that. And this is what I hoped you would do, and you did so beautifully, is to really make it real for everyday people to understand why this would be something. And what I love about this is it's so accessible. You spoke in your presentation about, drinking water and electrolysis. Can you explain, and Jen, I think you wanted to jump in with this too. What's the way we can deliver this? I know before I got on this call today, I was seeing patients this morning, and I was using my macro dose of molecular hydrogen this morning and had my water. And I tell you, as a therapist, when I'm treating, I feel clearer. I have more energy. And when I notice it, and I've seen through your presentation why I feel it right away. It's really remarkable. And so I wanted to talk a little bit about the delivery of it, whether it be Jen, whether it's through the macro doses or whether it's through, the type of vessel. Does the vessel matter when it comes to drinking out of for molecular hydrogen?
Yes and no. We have to consider some of the most objective criteria. The first and foremost is, are we actually getting molecular hydrogen? Is there hydrogen actually in the water? There are a number of products out there that they claim molecular hydrogen, but they don't actually provide a molecular hydrogen. Or they provide molecular hydrogen initially, but because of low maintenance or whatever, they don't have it. Like I mentioned about the water ionizers earlier, they can provide molecular hydrogen, and people have experienced benefits, and you can measure the concentration of hydrogen. But if you don't maintain the machine properly or what have you, then the concentration can go below the therapeutic levels. And then also the concentration may not be as high as what you want clinically. When we look at what the clinical studies actually say, we want a certain concentration and dose of molecular hydrogen, right? So the vessels can matter, but it matters only in so much that you are getting that consistent high dose of molecular hydrogen. And again, now that we know what is the therapeutic effect of these types of products, we can develop and optimize products so that they can give you a high consistent dose of molecular hydrogen. And that's when that vessel really becomes important. Those are the objective criteria, right? And that's when it comes to hydrogen and water. But then there's the subjective as well. So for some people, they may, like I know the Lumaviti, for example, they have two different hydrogen water products. They're the hydrogen producing tablets. Well, that's not only a hydrogen product, right? There's lots of tablets on the market. And maybe Lumavites are more expensive, but see, the Lumavite tablet is unique in that it also has these other ingredients, so that if people are maybe they want to try those other ones, maybe there's some synergistic effects. We've done a whole presentation on that LVIQ tablet before, and it's all based upon lots of good clinical research all combined together in this one tablet. And so it becomes sort of subjective whether somebody is going to say, okay, that's how I want to do it, or maybe somebody else doesn't want to, or they want to do both, and so on, right? That's a kind of a different criteria, but that's held to a level of saying, what does the clinical data show, right? And then you have like the different bottles that are on the market in general. Like you could just run out to Amazon and buy the cheapest thing, and if you did that, you may or may not get what you were hoping to get, right?
And thank you for mentioning that. And that's exactly why these conversations with people like you and researchers, because we live in an age where anybody can Google anything. You can find it, on Instagram, somebody saying something. But this is exactly why learning from people like you, Tyler, and understanding what we're looking for. Christy in the comments is asking, what is a therapeutic dose? So yes, the type of vessel matters, the dose matters, and hence why doing this kind of education is why FAM exists. Can you speak to therapeutic dose so people understand when they're looking at this?
Yeah, and that's still more research is emerging with that. Well, typically we just have to look at the clinical studies, and the lowest clinical study that we have seen a therapeutic dose of molecular hydrogen is you need at least 0.5 milligrams of molecular hydrogen in order to get a therapeutic dose. That doesn't mean it's the optimal amount at all. It just means that is studies have shown that is the lowest amount where that specific study showed there was a benefit. Other studies require a higher amount, right? So we can't simply say, okay, as long as you get this, then you're going to be. Typically, when it comes to hydrogen water, this is different than inhalation. When it comes to hydrogen water, a higher dose is either more effective or at least as effective as a lower dose is. So we tend to actually want to get a higher doses, higher concentrations of molecular hydrogen. That's likely to be more therapeutic or more effective for several reasons. One, maybe it's going to help with more types of conditions. Maybe it's going to help with a more wide variety of populations, different people, because everyone responds differently, have different needs, different metabolisms, different genetics, and so forth, right? So we like to focus on a higher concentrations of hydrogen. And the number one reason why is because there's no data for hydrogen water that lower concentrations are ever more effective than higher concentrations. There is data that a higher concentration is just as effective as a lower concentration. Okay, it's like in Parkinson's disease, there are some studies where a high concentration did not seem to be any more effective than a low concentration, but it was still just as effective. Okay, it wasn't less effective. And yet there are other studies like the metabolic syndrome and mitochondrial situations potentially where higher concentrations and higher doses did seem to be more effective. And that's why there's kind of an emerging idea that, okay, getting a higher dose of when it comes to hydrogen water, then that is a better thing to do. And then it's not only the dose that matters also, but it's also the timing. Because remember, when we look at the pharmacokinetics of molecular hydrogen, it's out of your body within an hour. So you're literally removing the hydrogen gas very quickly. In order to get a therapeutic threshold in your cells, you have to ingest a dose high enough that it reaches a cellular concentration high enough before you expel it out. Consider if you were to ingest hydrogen at the same rate that hydrogen gas is leaving, then you would never increase the concentration of hydrogen gas in your cells. So this idea, maybe just sipping the water throughout the day, you potentially never actually increase the concentration of hydrogen gas in your cells. Consider like when we're inhaling normal air, the atmospheric air, which has like 21% oxygen, has about 0.000055% hydrogen gas. And we can breathe this all day long, and yet none of us are protecting ourselves from stroke and other diseases like we saw in that study. Although I guess it does raise the question, what if you had zero hydrogen gas? Would there be a little bit of benefit? Probably not, because we can see dose-dependent effects in some of these things. So when it comes to the drinking hydrogen water, we typically like to say, drink it immediately. It's not like instantly, right? Sometimes there are skeptics out there, well-meaning, potentially educated, where they believe that when it comes to hydrogen gas not being super soluble in water, because it's not, it's a non-polar molecule, that as soon as you finish making hydrogen water, it immediately evaporates. It's immediately gone from the water, for example. And it's not. It's just like carbonated water, right? When you open it up, it still stays in the water for, maybe even hours, and you can still drink it and still taste that fizz, right? Same thing with hydrogen water. But of course, you're shaking it around and everything and moving it, then of course the gas is going to go out quickly. But the bigger reason why you want to drink it quickly after you open it is not so much because you're preventing the hydrogen gas from leaving the water, but rather because you want to get the gas inside of you to reach a high enough concentration before it just goes right back down to baseline, where in that case, it's like you didn't do anything to increase the cellular concentration of the hydrogen water. Does that make sense?
It sure does. Yeah.
Yeah.
Jen.
I'll close because I want to be honor your time, but I thank you so much for sharing all this knowledge and really supporting us as molecular hydrogen does go mainstream, like you say, by 2037. That is just so exciting. But to also just be informed consumers and understanding that as it goes mainstream, we have to educate ourselves of what to look for, what to avoid in things that are coming into the market. And I'm so excited to meet you in person in Portugal in just a couple of weeks at our event Luminaire. And thank you for taking the time. You're traveling, you're in between places as we speak, you're at an airport. I really appreciate that. But it just speaks to your commitment in educating all of us on molecular hydrogen and its health benefits. I'm just curious, just to wrap up, what are you most excited about in coming to Portugal and to speaking with us within our community? I know we're all very excited to meet you. There's lots of us on the call today who will be there. What are you most excited about educating us on in our community at Luminaire?
Yeah, first off, I want to say thank you for everyone on this call and for the opportunity to express my passion of this research in this area. There's sometimes a lot of misunderstanding about this. But I think having this opportunity to educate, I think it's really important because we have worked really hard on this research, right? And I think it's really important that people understand how to get good hydrogen products And when it comes to the hydrogen water, you want to make sure that it's meeting certain criteria, right? Just like with the inhalation, because it's explosive, you have to be careful with that. There's so many things. And so I feel like um, I have just a lot of gratitude for everybody here for their interest in this area, and now being able to go to Portugal and further its education and to meet everybody in person. That speaks a lot to my heart because we're kind of all the same community and desires and passions, and that's a really neat thing to all be in the same room and be able to talk about all of this. It's not that we're just passionate about hydrogen, right? Hydrogen is the word we're using, but it's a passion for life and community and for growth and for healing and for all of this together. And that's what I love about hydrogen is it sort of encaptures all of this together. And so I think I'm just excited most about being able to come to talk to a group of people who we share those same common feelings and those same desires for education and for understanding, where we can then take that information back and help not only ourselves, but those that we are close to and those we are not close to, where we can really, shine the light of this education to the world. And that's why it's so important to me that we learn the principles of critical thinking and evaluation of evidence so that we can really help other people as well and not just ourselves. We don't want gurus in our life. What we want is good critical thinking, the power that the divine has already given us so we can know how to evaluate things that make the best sense for us so we can all have well-informed consent. So thank you, everyone.
Tyler, okay. So that was a mic drop moment. And I have to say this, I am so honored as the founder of PHAM, Preventative Health Awareness Movement. You are officially welcomed into the family. It's a
Thank you.
growing, it is a growing family, not just of healthcare professionals, but thousands of everyday people that want exactly that, want better for themselves, want better for others, want better for this world. And that's what education does. That's what community does. And that's what days like this do. So welcome to the family. For those that aren't going to be fortunate enough to be in Portugal, this is why we're doing this. I'm going to be sharing this through all of our channels. I would love to have you on my podcast and TV show. We will be sharing this through a blog. I've got so many people waiting for this recording because they couldn't be here in the middle of the day, even though you were so generous to give your time today. So I just want to formally, from the entire family, the Preventative Health Movement, thank you, Tyler. Thank you for your wisdom. Thank you for your hard work and passion. And I look forward to elevating your message. And I love nothing more than being, on the the early day adopters of everything, because that's how we create change in healthcare. And together, we're going to change the legacy of healthcare in this world. And we're doing this person by person, doctor by doctor, and moment by moment like this. So thank you. Thank you, everyone, for joining us. Stay tuned. You will be sent the recording as well as the transcript. If you've got questions, you can fire them back. Be sure to follow Become the CEO of Your Health on Instagram and all the other channels. Become the CEO of Your Health on YouTube, because you're going to see Dr. Tyler, right? Dr. Tyler, you're going to come on my show?
We can do it. We're all about education. Thank
Yeah.
you.
I love it. I love it. And safe travels. Thank you, everybody. Enjoy your day,
Thank
and
you.
we'll see you all soon. Bye for now.